Okay, guys, I have something very serious to talk to you about. Okay, I didn't want to bring it up because I just didn't think it was the time. But I think now that it's very important to talk about this. Double chin. No, that's not what we're talking about. Jackson's messy writing. Okay, I'm literally, I just can't handle it any longer. It is out of control. No one can mark it. It's just terrible, you know? I had to bring it out. I feel so much better now. I feel like I can breathe and we can carry on with the lesson. If someone could help Jackson out with that messy writing, that would be great. His notes are just all over the place. It's just a disaster, okay? I feel so much better now that I brought that up. All right, I think we can do notes now. All right, so trig limit laws. So we have a few rules that I'd like to go over. So the limit is x approaches c of sine x. If they gave you that, you could just plug c in for the x, and then you'd give me the answer. So for example, if it was like sine of 0, okay? Say it was in radians. Sine of 0 is what y is at 0 radians, which would be the answer 0, okay? And then they could say sine of, they could say as it approaches 90, as it approaches 180, all that stuff, okay? Same with cos. This is the key thing. So if I actually punch that into my calculator, sine x over x, erase all this lovely stuff from before. I go alpha y equals, enter, sine x over x. And we're in calculus, so I am going to do it in radians, because that's the helpful kind. And I'm going to go zoom trig so you can see it. Okay. Now, back here, what we're doing is, as it approaches 0, as x approaches 0 of sine x over x, what does y approach, right? That's what we're asking. Because remember, limits are what I approach. Not, it doesn't have to be what the value is at that spot, because it could be an asymptote, or it could not exist, or it could be a point of discontinuity, or the graph could be piecewise. In this case, it's saying, of the graph sine x over x, as I approach 0, what do I approach on the y? So as I approach 0 from the left, and I approach 0 from the right, they're both approaching 1, right? So as I'm approaching 0 from the left, as I'm approaching 0 from the right, they're both approaching 1. So then I can say that the limit as x approaches just 0 is 1, because from the left and the right it approaches the same thing. And the same thing goes with 1 minus cos x over x, it approaches 0 for another day. We're going to look mainly at the sine x one. Okay? So this first example, what did I tell you to do when you evaluate limits? The first thing I told you you should always do is plug in the value and see if it works, because you only have to deal with it in a different way if when you plug in 0, you get a 0 in your denominator. Or if you plug in the value, you get 0 in your denominator. Okay? So I'm going to fill it in. I'm going to go cos of 0, because that's the first thing I try every single time I get a limit. Sine of 0 minus 3. Okay? Remember, it's always in radians. And if it was in degrees, it would have to have a degree symbol, which it doesn't. Cool thing about 0 is if it's in degrees or radians, it gives you the same answer. So cos of 0. At 0, little unit circle, at 0, my point is 1, 0. Remember, this is cos, this is sine of 0, this is cos of 0. So sine of 0 is 1, or sorry, cos of 0 is 1, and then sine of 0 is 0 minus 3, and so I get negative 1/3. Look here, same answer. How could I check it? I could plug cos x over sine x minus 3 into my y equals, and see as I approach 0 from the left to the right, I should be approaching negative 1/3. And this one would actually equal it at that value because this graph exists there. If I can plug in right into the limit and I don't get a 0 in the denominator, that means not only from the left and from the right it approaches that same value, but also that value it does. It's continuous. Okay? So the first thing you always want to do is try and plug it in. B, if I go to try and plug it in though, ruh-roh, I have a 0 in the denominator instantly, so that's not going to work. So we kind of use a little bit of what we learned in the infinity lesson. That's why I like doing these two together. I can divide every term by the same thing as long as I pick the same thing, right? And I know from up here that if I can get it in the form sine x over x, then it will turn to a 1, right? Right. Okay. In this case, I don't even have to divide because I just need to get sine x over x. So I can actually go sine x over x times 4. But how can I do that? So I need to go sine 4x over x. Now I need this to actually be, if I get sine x over x, I get 1. If I get sine 4x over 4x, I get 1. So I need this to be a 4x. And that'll become a 1. But can I just randomly do something to the bottom of an equation and make it the same? Nope. If I'm going to multiply the bottom by 4x, I need to also multiply the top by 4. Sorry, I multiply the bottom by 4. I have to multiply the top by 4. So what am I going to get? I'm technically going to get 4 times sine 4x over 4x. Remember, you can split them up. We can put this over a 1 if we really wanted to. And what's sine 4x over 4x as I approach infinity? Ooh, I'm forgetting to write my limit. How sad is that? The limit as x approaches infinity, or not infinity, 0. The brain's still stuck in infinity. The limit as x approaches 0. Okay? As I approach 0 on 4, 4 stays a 4. As I approach 0 on sine 4x of 4x, I get times 1 because of the rule up here. If it's an x or 4x over 4x, it still works. So I get 4. And the limit went away in this step because I applied it to the sine 4x over 4x. Okay, what's my problem with C? I have sine 2x over 5x, and I need it to be sine 2x over 2x, right? Okay, so what can I do? I'm going to have to multiply this bottom by 2. So I'm going to rewrite my limit. Limit as x approaches infinity, or oh my gosh, I'm stuck in infinity. Sine 2x, it's 0, not infinity, over 5x. Okay? I need it to be a 2x in the bottom. So I'm going to times this by 2, and I'm going to times this by 2. And I'll show you what happens. So I'm going to go the limit as x approaches 0 of sine 2x over 2x. But what's left over in the bottom? A 5, right? So I can multiply the 5 over here. And what's left over in the top? This 2, right here. And what happens when I apply the limit? Sine 2x over 2x becomes a 1 times 2 over 5. And I get 2 over 5. D. Now's the conundrum. I have 2 things, okay? When I have 2 of these, I will split them up sideways because it seems like more work in the end, but you won't make a mistake. So I'm going to go the limit as x approaches 0. The previous ones have been just one sign, right? One sign in the top. This one has a sign in the top and a sign in the bottom. So I'm going to split them up with a sideways division sign. So I'm going to go sine 7x divided by sine 3x. Okay? Now, I'm going to treat them separate. So this one, I need to divide by 7x, right? In order to get to go away. And what I do there, I have to do the top, because I can't just do it to one side. Then the 3x one, I need to divide by 3x. Not just the 3, there is no x down there, so 3x, and I have to also do it to the top. Following along. Then we get the limit as x approaches 0 of 7x times sine 7x over 7x divided by 3x times sine 3x over 3x. Now, if it makes it easier for you to see, I'm going to put the top in brackets, the bottom in brackets. Okay? As I apply my limit, I get the limit as x goes to 0. 7x stays 7x times, now, sorry, the limit is gone. I'm going to apply the limit. So as I apply the limit in to both of these, 7x stays 7x times sine 7x of 7x as I approach 0 becomes, do I want to fill it in yet? No, I don't want to fill it in yet because this would become a 0, right? Let's not fill it in yet. Let's do some more reducing. So we're going to get the limit as x approaches 0. If I plug the 0 in right now, the 7x would become a 0, and I don't want it to become a 0. So I have to do some more work. So I'm going to get 7x times sine 7x over 7x. This whole thing, technically. And then I'm going to go multiplied by 3x multiplied by the 3x over sine 3x times 3x in the bottom, right? Technically. I'm going to put them all together so it makes a little more sense in a second. So I'm going to go to the limit as x approaches 0. I'm going to write the sine, because these can all be written together now. It's multiplication. So this can technically be written together like one big thing. So I'm going to go sine, oops, put it in the wrong spot, sine 7x over 7x times 3x over sine 3x times 7x over 3x. The x's cancel. And so when I apply it, I'm going to get 1 times 7 over 3, which equals a 7 over 3. And once again, you can type it into your calculator and you can check it. And that is the end of that.